Hello and welcome. Today we will be discussing how to divide polynomials, first by using long division, then we're going to synthetic division, and then we will learn what exactly the remainder theorem is. We will have timestamps in the description to show you exactly when each section of the video is starting, and it will be shown on screen, so if you drag at the bottom of the screen, for instance if you're on mobile and cannot copy paste the timestamps, you can easily just slide through the bottom and see where the titles are. It should be pretty easy to tell based on how we're going to be in Paint this entire time, well specifically Microsoft Paint, and that should give a clear contrast between the white and the black colors at the bottom of the screen when scrolling through YouTube. Now I know this may seem like a really basic problem. Everyone learns this in either 3rd or 4th grade, maybe even 2nd grade now. I'm not sure, I just know we learned it early. But it is important to know this, as all the elements shown in this problem will be coming up again. By the way, if I'm pointing at something and it looks weird, I have the screen here and it's going to look different. Like, I'm pointing at the 17 right now. It's going to look weird on screen. But that's besides the point. First, we're going to take this 17, and we're going to try to put it into this 9. But we all know 17 is greater than 9 in the number system. Therefore, we got to put it into the next digit along with the first digit. So, how many times does 17 go into 92? The answer to this would be 5 times. That is a horrible 5. Let me redraw that. So next, we multiply 5 by 17. A lot of people like to put the arrows. I do not. But whenever you do this, you're going to get 85, which you write under the 92. Next, you change all the signs of any terms that you have under your first term. Now, the way I do this is I just put parentheses around everything, then put a subtraction sign, or a negative sign, whatever you want to call it, and then distribute in my head. Now, for most people, they can't do that, so it may work better if you just put the sign in manually. For me, I just like to put the parentheses and do that. Now you add the two terms together. Now you may think I'm crazy for doing this, as, oh, no, you're supposed to subtract in this. That's what I learned. But you would be correct in this. You are actually adding them. You are actually adding all the way back when you learned this. You are just adding a negative 85 to 92. You can also just say subtraction. So, 2 minus 5, I'm just going to do that in my head, it's 7. You can do long subtraction if you want, but usually you can do it in your head pretty easily. Now, we still have this 5 here to deal with. We're just going to bring it down here, and we have 75. Now we're going to go back up here to this 17. How many times does 17 go into 75? According to my notes, that would be 4. Of course, you have multiple methods on checking how many times something goes into something. So we have 54. 4 times 17 is 68. Again, parentheses, negative. That looks horrible. I'm going to just redraw that whole thing, it's annoying me. Drawing with a mouse is hard, by the way, but that's besides the point. What is 75 plus negative 68, or just minus a positive, is 68? That would be 7. Now, what do we do with this 7? We know it's the remainder. Most things will have you write remainder 7. That's probably how you learned it. Today, what we're going to do is we're going to take the remainder here, and we are going to take our divisor, and we're going to make a fraction out of them. Remainder over divisor. And that's going to be the fraction that goes along with our solution, also called a quotient. The quotient of 925 divided by 17 is 54 and 7/17. Now, that was how to do it with normal numbers. We will now be moving on to how to do this with polynomials. We will now be looking at polynomial long division instead of numerical long division as we have just looked at. To start off, we're going to do the same thing. We're going to put the divisor into the dividend. So, x plus 2 into x cubed. Except we will be ignoring the 2. That's just how it works. So, how many times does x go into x cubed? Initially, you may think, oh, it goes 3 times. But if you multiply 3 by x, you're going to find that you get 3x. So we got to multiply in terms of x if we want to get x cubed. A simple way to figure this out is to put it in fraction form. For instance, x cubed over x, which is x to the first. 3 minus 1 is 2, which means you get left with x squared. I cannot apparently draw or think about numbers while drawing them. Another way to visualize this may be to put 3 x's in the numerator and 1 in the denominator. This way you can see that x's will cancel each other out, leaving you with 2 x's at the top, also known as x squared. Now that we have visualized that, let's get on to the problem. So x squared is what goes into this. Now, I like to line up my terms. You may not. You may. It depends on your personality. You may like aligning the terms. Some people will prefer to put the x squared here than everything else later, and that's perfectly fine. Me, I like to do this. Next, we will multiply the number on the top by everything in the divisor. So first we'll multiply it to that, then we'll multiply it to that. I personally do not like the arrows there, so I just do it in my head. You may need the arrows at first to help you. So x squared by x is x cubed. X squared by 2 is a positive 2x. Now, what we're supposed to do here is change the signs on everything. Manually putting in the signs is what most people do. Now, what I do is I put parentheses around this, and then I put a subtraction sign on the outside. It's just how my brain operates. Your brain may operate differently than mine, though. So, to each their own. Now, these first terms will always cancel out, no matter how far we go down. For instance, if we have something down here, and we go down, the first 2 will always cancel out. Now we have 6x squared minus 2x squared. I did not put the squared there. My bad, I got confused for a second. We put our line here, and we are left with 4x squared. The next step is to bring down the rest of the terms in the equation. In this instance, it is a positive 5x and a negative 8. Now, how many times will x go into 4x squared? Well, let's put it in fraction form. 4x squared over x to the first. And to get this to cancel out, we have 2 minus 1. This cancels that out, which is that. We are left with 4x. So, positive 4x. Now we multiply this by everything over here. So that by that, that by that. Again, I do not like the arrows, and the arrows will get crowded on paper. So 4x by x is 4x squared. Again, these will always cancel out. 4x by 2 is a positive 8x. I then put my parentheses in and subtract. Most people do put the signs in there on their own. I do not. So 4x squared minus 4x squared, that's nothing. 5x squared minus 8x, that is a negative 3x. We will now bring down the negative 8. This negative 8 will be brought down until we have our remainder at the bottom. So, how many times does x go into negative 3? negative 3 times, because negative 3 by x is negative 3x. So again, multiply that by that by that. I think you get the gist of it by now, so we're going to keep going through this just in case though. Negative 3 by x, negative 3x. These will always cancel out. Again, so, and then negative 6. Parentheses, subtract, or changing the signs themselves. I personally do not like doing that. I just do it in my head. And we are left here with a negative 2. But x doesn't go into negative 2. So that's how we know we have reached our remainder. When the degree of our remainder is less than the degree of our divisor. In this case, this would be technically 2x to the 0th power, which will just be 1. Anything to the power of 0 is 1. So negative 2 by 1 is negative 2. Therefore, that's just how we have it here simplified. Now, to get our fraction up here, instead of putting remainder negative 2, as you may have learned in 3rd or 4th grade, you put your remainder over our divisor. In this case, subtract 2 over x plus 2. And here we go. Here's our full quotient. X to cubed plus 6x squared plus 5x minus 8 divided by x plus 2 has the quotient of x squared plus 4x minus 3 minus the fraction 2 over x plus 2. Next, we will be learning synthetic division. Remembered it. We will now be learning how to do synthetic division. The important thing to know is that you can only divide using synthetic division when our divisor here is a power of 1. For instance, if, let's say we just had these reversed and this was the numerator and this whole thing was the denominator. X is to the power of 3 here, not 1. Therefore, we cannot use synthetic division, and we're going to have to use log division for that, although that would be a pain to do. So we're going to use this setup here. We're going to have a little box here. We're going to have a line. We take the second term in our divisor, 2, and we write the opposite of it here. Now we take all of our coefficients, in this case 1, negative 14, 51, and negative 54, and we're going to write them along here. So 1, negative 14, 51, and negative 54. So, our first step is to drop down this one. And then we're going to multiply it by whatever number is here, in this case negative 2. We will then move that number under here. I personally like this arrow here. I don't like moving the arrows around though. So, minus 2. Negative 16 is what you get when you add negative 14 and negative 2. Now you multiply that by that and move it over there. Again, I don't like those arrows. So, that will give us 32, which when added will give us 83. You then multiply that by negative 2 to get a negative 166, which will add to a negative 220. Now, let's take a look at this x cubed and this x. X cubed over x, as we have stated before, is equivalent to x squared. Now, this is important, because this first term will be our squared one, followed by our to the power of our x to the power 1, then our x to the power of 0. Now, you may think, What in the world is this negative 220 doing? Ah, that is our remainder. So, we have x squared minus 16x plus 83. Technically, it's multiplied by x to the power of 0, which is 1, multiplied by 83, which simplifies to 83. Now, our remainder will always be above. It will be the numerator in a fraction we're creating, and this will be our denominator. So, since we have a negative 220 minus 220 over x plus 2. And there we go. That is our quotient for this division problem. Next, we will be learning about the remainder theorem. Oh, I'll move this, that way you can actually see my work though. Take a couple seconds to look at it as I did not plan my webcam. So yeah, that negative 220, this is our remainder. That's what you get when you get that. That's how it relates to the quotient. My apologies for that. I hope you followed. Now we are moving on to the remainder theorem. What the theorem officially says is if you divide a polynomial p of x by degree n is greater than or equal to 1 by x minus a, then the remainder is p of a. Now, I'm never going to remember that. I don't think you will either, although you may. Different people, different ways of thinking, different ways of memorization. So, what we're going to do with this is we're going to do a form of synthetic division for our problem. As you can see, it's asking what is p of 3. Now, by doing this, it's basically asking us for our remainder. So, by the remainder theorem, p of 3 is the remainder when you divide p of x by x minus 3. X minus 3. The opposite of that is 3. Do we remember what we put in the box here? The opposite of our divisor, which in this case is x minus 3. I think we see the connection between here. The opposite is that. I need to get rid of that first. My bad. So, 3. Now we're going to put in all of our coefficients, even if not stated. As you can see with this problem, we have nothing to the power of 4. Therefore, our coefficient is 0, as 0x to the 4th is 0. So let's write that all in. 1, 1, 0, negative 2, negative 1. We actually have no x's as well, so we need a 0 there. And 2. Again, we have no x here because 0x is equal to 0. So, we first move our first number down. 1 by 3 is 3. Add those to get 3. Multiply these to get 9. That 9 looks horrible. 9 minus 2 is 7. 7 by 3, 21. Subtract 120. Multiply 3, 60. Add those together, that's 60. Multiply by 3, that's 180. And that's 182. Now our remainder is always what it is. So, since this is x to the 5th, we will have 4, 3, 2, 1, and 0. Then we cut off, and we have our remainder, which is 182. Therefore, p of 3 is equivalent to 182. Thank you for watching today. I hope that you have learned how to do division based off of this, long division in terms of numerical and polynomial, synthetic division, and learned about the remainder theorem. If you need any further questions answered, just feel free to contact me in any way you can through Discord. If you have my number, text me. Do whatever you need to do to contact me in order to learn more about this subject. Or if you need help with a specific problem, I'm always willing to help. Thank you, and goodbye.